Hi all. Today we are going to do the fifth example from electric charges and fields. Question is given here. Consider three charges q1, q2, q3 each equal to q are placed at the vertices of an equilateral triangle. Equilateral triangle means triangle with all sides equal, all sides of same length. In the question they had given us the length as L, and they also told you there are three charges and all the three charges are having the same value. So q1 equal to q, q2 equal to q, q3 equal to q. And you have to find out another charge q is placed at the centroid of the triangle. What is the centroid of the triangle? It's a point where the three medians of the triangle meet together. At that centroid, another charge q is placed, and they had given charges of all the charges here. All are having the same sign. And you have to find out what is the total force acting at the center. Okay. As you can see that there are three charges at the three corners. All these charges will give force to the charge at the center. This first charge will give a force. The second charge will also give a force, and the third charge will also give a force. You can see in the picture that the first charge q1 is giving a force to q, and it is marked as F1. And its direction is also given here in this direction. This q1 is giving to force to q. So this is in this direction. Okay. Again, this second charge q2. This q2 is also giving a force to the charge at the center. Its direction is in this direction. And this third charge q3 is also giving a force, and that will be in this direction. Okay. So first, it is given that all these charges are equal, and we took it as q. Side of each length of each side is taken as L. We don't know what is the value of this distance, because for finding the force between these two charges, we need 1 by 4 pi epsilon 0 q by r square. So r is a separation between those two charges. We don't have that separation in our hand. So our first step is to find out what is the value of that distance. Okay. So for finding the value of the distance, first we have to take this right angular triangle ADB. Okay, that right angular triangle. In that right angular triangle ADB, when you apply the Pythagoras theorem, you will get this AD. This missing side AD is equal to what? AD square is equal to hypotenuse square minus base square. That means AB square minus BD square. AB square minus BD square. Okay. So it's written here. What is AB? AB is the length of the triangle L, right? So L square minus BD square. BD is what? Half of the length, right? This is, since this is a median, each will be L by 2, L by 2. So L by 2 square. That means L square minus L square by 4. And when you take the LCM and do multiplication, you will get 4L square minus L square. That is 3L square by 4. So we got AD square as 3L square by 4. Then what will be AD? What will be AD? AD will be, you have to take root 3. Root of L square is L and root of 4 is 2. So it is root 3L by 2. Another important thing that you have to know here is centroid. That means the center point. The centroid will divide the median in the ratio 2:1. Centroid will divide the median in the ratio 2:1. Okay. So the length of this OA will be then 2 by 3 of the total. 2 by 3 of the total. So OA is equal to 2 by 3 times. What is the total length? 2 by 3 of AD. AD is, in the previous step we got root 3 L by 2. 2 and 2 can be cancelled. Okay. Root 3 and 3 can be cancelled, which will give root 3 at the bottom. So the final answer will be L by root 3. OA is equal to L by root 3. And you know that by symmetry, this OA, OB, OC, all will be same. OA, this is OA, this is OB, this is OC. These three will be same. So it is OA is equal to OB is equal to OC, equal to the same answer, L by root 3. Okay. So we got that. Now we can find out each of the forces separately. First we can find out F1. What is F1? F1 is the force given by Q1 to capital Q. Okay. So force on capital Q due to the charge at A. What is the formula? 1 by 4 pi epsilon 0 Q1 Q2 by R square. So our charges are capital Q and small q. Q by R. What is the distance here? We found out in this step. L by root 3. L by root 3 square. When you take the square of this L by root 3, it will become L square by 3, and that 3 goes to the numerator, and you will get this equation 3QQ divided by 4 pi L square. 3QQ divided by 4 pi L square. Okay, 4 pi epsilon 0 L square. And what is the direction? From A to O, AO, along AO. In the same way, you can find out the force on Q, do capital Q due to Q2. The same answer, 1 by 4 pi epsilon 0 QQ by L by root 3, because this is also L by root 3 square. So you will get the same answer, and the direction is from B to O. Okay. Now F3, the force due to the third one, this one, is also the same value. The direction will be from C to O. So in the diagram, you can see there are three forces here. All the three forces are having the same value. Now we have to find out the total force at Q. For finding the total force at Q, look here in this picture, you can see that this is 90. This is what? This is an equilateral triangle. Corner angles will be 60. So this angle will be 30. 90, 30. So what will be the balance angle? 60, right? 60. If this is 60, this will also be 60, right? So 60 is plus 60, 120. That means this angle is also 120. This angle is also 120. You can see that this F3 and F2, these two are forming like the sides of adjacent sides of a parallelogram. So for getting the resultant of these two, this will be resultant, and for getting the resultant of these two, you have to use the parallelogram law of vector addition, which you studied in grade 11. What is the equation for finding the resultant force? Resultant force is equal to, you studied the equation F1 square plus resultant force F is equal to F vector is equal to root of F1 square plus F2 square plus 2F1 F2 cos theta. Right. So here our forces are F2 and F3. So the resultant force F is equal to root of F2 square plus F3 square plus 2F2 F3 cos theta. So F2, F3 all are same. Values are same. So you can put it as F. So root of F square plus 2F square. And what is the angle I told you? 60 plus 60, 120. Vertically opposite angle. So this angle will also be 120. Cos 120. What is the value of cos 120? Minus half. So when you substitute that answer, you will get like root of 2F square plus 2F square cos 120. Cos 120 is minus half. So root of 2F square minus F square, and that is root F square, and root F square is what? F. So we got the resultant of these two forces as F in the upward direction. Okay. You already have another force F in the downward direction in the previous step, right? So what is the total force on Q then? The total force on Q will be, what is the total force in Q? In a total force at that centroid O will be along this direction. This direction is marked as R cap in your book. So F R cap in the top direction, and in the bottom direction also the next force is F, but the direction is opposite, so you can write it as minus F R cap. So the net force on that point will be F R cap plus minus F R cap. When you take R cap like F common outside, you can write like R cap minus R cap, that will become equal to 0, which means that the net force that acts on the centroid of that equilateral triangle will be equal to 0. And hence we proved it. I hope all of you understood this, and we can do the next example in the next video. Thank you.